Welcome to Security Fundamentals. My name is Sarah Alali. I work at Microsoft and I will be your trainer for this session. I have a PhD in computer science and over 10 years experience in teaching, training, and also in conducting research. And I have a passion, guess for what? It's for technology, and I love to learn new things. Security and compliance are essential aspects of any organization that deals with data and information. Security refers to the protection of data and systems from unauthorized access, use, modification, or destruction, while compliance refers to the adherence of laws, regulations, standards, and policy that governs how data and information are handled. This course covers 6 different sessions. You are encouraged to watch one or more sessions. In this third session, we are going to cover some of the capabilities of Microsoft Security Solution. So let's go. So with this session 3, we will talk about Microsoft Security Copilot. And we are going to go over some of different security solutions in Azure especially. Let's start by exploring more Microsoft Security Copilot. Organizations are dealing with an increase in the number and sophistication of attacks. There is also a talent shortage driving the need of automation, integration, and consolidation of security tools. Organizations need to act quickly to address these challenges. Working at human speed isn't enough. Even without a talent shortage, we need to work at machine speed. Microsoft Security Copilots came to solve all these problems. So, what exactly is Microsoft Security Copilot? It's an AI-powered, cloud-based security analysis tool designed to help analysts respond to threats quickly and efficiently. By processing signals at machine speeds, it allows us to assess risk exposure much faster than traditional methods. Microsoft Security Copilot combines powerful large language models, LLMs, with a security-specific model from Microsoft. It integrates with both Microsoft and non-Microsoft sources, learning at machine speeds to help us identify and respond to emerging threats. Plus, our enterprise data is protected by comprehensive compliance and security controls. Now, let's explore some of the key use cases of Microsoft Security Copilot. First, we have incident summarization. This feature distills complex security alerts into concise, actionable summaries, making it easier for us to understand and respond to threats quickly. Next, there is impact analysis. This helps us assess the potential impact of security incidents, enabling quicker response time and streamlined decision-making. Another great feature is the reverse engineering of scripts. It analyzes complex command line scripts and translates them into natural language, providing clear explanation of actions. Lastly, we have guided responses. This provides actionable step-by-step guidance for incident response, including directions for triage, investigation, containment, and also remediation. Microsoft Security Copilot offers both standalone and embedded experiences. With the standalone experience, you can experience Copilot through the dedicated site. Users interact with Copilot through the prompt bar. In the prompt bar, users make requests in natural language and then receive response output as text, images, or documents. Microsoft Security products embed Copilot capabilities directly within the product's user interface. This experience is referred to as embedded experience. So, let's be familiar with some of the terminology of Microsoft Security Copilot. First, we have session. This is a particular conversation with Copilot. We have also prompt, a specific statement or question within a session. A user enters a prompt in the prompt bar. We have also capability, which is a function Copilot uses to solve part of a problem. A capability may sometimes be referred to as a skill too. We have also plugin, which is a collection of capabilities by a particular resources. Finally, orchestrator, which is Copilot's system for composing capabilities together to answer a user prompt. In the previous session, we gave an example of a plugin, which is a Microsoft Intra. However, this is not the only example. Copilot integrates with various sources through plugins, including Microsoft's own security products, such as Microsoft Sentinel, Defender XDR, Microsoft Intune, and also non-Microsoft solutions and open source intelligent feeds. The integration enabled by the plugin for any specific data source provides Copilot with a collection of capabilities. Each capability is like a function in software. It's designed to do a specialized task within the scope of the data source. The capabilities also serve as prompts. You can select capability and it will run as a prompt. So, how does it work? The process starts when a user submits a prompt in the prompt bar. Then, Security Copilot sends the information to the Copilot backend, referred to as the orchestrator. The orchestrator is Copilot's system for composing capabilities together to answer user prompts. It determines the initial context and builds a plan using all the available capabilities. Once a plan is defined and built, Copilot executes the plan to get the required data context to answer the prompt. In the course of executing the plan, Copilot analyzes all data and patterns to provide intelligent insights. These include reasoning over all the plugins and source of data enabled and available to Copilot. Copilots combine all data and context and use the power of its advanced LLM to compose a response using language that makes sense to a human being. Before the response can be sent back to the user, Copilot formats and reviews the response as part of Microsoft's commitment to responsible AI. The process culminates with the user receiving the response from the Copilot. If we want to write an effective prompt, we should include the following elements when writing prompt. First, the goal. What specific security-related information that we need? Then, the context. Why do we need this information, or how will we use it? Next, the expectations. That means format or target audience we want to response or tailor to. Finally, the source. We need to make sure to give information data sources or plugin Copilot should use. Now, let's talk about how to enable Microsoft Security Copilot. This process involves a few key steps to ensure everything is set up correctly and efficiently. First, we need to provision Copilot capacity. Microsoft Security Copilot is sold as consumptive offering, so we need to provision security compute units, SCUs, which are the computing power used to run Copilot. Next, we need to step up the default environment. This includes allocating SCU capacity, setting the geographic location for data storage, and configuring data sharing options. Finally, we need to assign role permissions. This step ensures that the right people have the right access to use and manage Microsoft Security Copilot. All right, let's see Microsoft Security Copilot in action. So here I'm in the simulated environment of Microsoft Copilot for Security. So we are looking into the standalone experience. And you can notice here we have a sandwich menu where we could access into different information. So we have home, my session, and in my session I could look into all sessions that I have done with the last update, when it was created. I could look also into the recent sessions. I could also put a filter and apply it to look into different session if I need to. Getting back into the sandwich menu, I could look into prompt library, and here I have different prompts. I could look the input, the plugins, tag, owner too. I could look into my prompt books. So I have one prompt book. I could look into my tenant prompt book. I could look into Microsoft prompt book. And also I could apply a filter and look into specific prompt book. Getting back, I could also look into information related to owner. So I have here owner settings. I could look into Azure resource links. I could look into security compute units that I'm using. Currently it's 3 units. I could also help to improve Copilot, so I could adhere to which data should be shared or could be shared, gathered by Microsoft. So I could allow Microsoft to capture data from Copilot for security to validate product performance using human review, or could say no, I don't accept that. I could also allow Microsoft to capture and human review data from Copilot for security to build and validate Microsoft Security AI models. So I could adhere or not to this. I could look into plugins for Copilot for security, so who can add plugins, contributors, or owners only. I could also allow Copilot for security to access data from Microsoft 365 services. So at that moment, I could experience more services that I need if I choose to add these settings. Also, I could configure who can add files in here in this Copilot. So it could be no one can add files, or also I could say it's okay if contributors and owners are able to add files. This is related to owner settings. I could look into role assignment, and here I could look into the owners that I have in this tenant, also the contributors that exist. If I get back into usage monitoring, so I could look into the usage of my units, of my compute units, and I can decide if I have enough compute units or I should increase it. And I could also filter it last 24 hours, 3 days, 7 days, depends to what I want to do. Also here, if I click on word group, here it's my tenants. I could see which tenant I'm using. I could also decide to switch tenants if needed. If I get back into home, so in here I have the last session, so I could continue my last session. I could also look into different prompts. So from here, I could also view all the sessions. So if I click in here, it gets me back into the different sessions, so the menu that we were seeing previously. I could also look into here the prompt, and also I could view prompt library. So if I go there, I will be redirected to prompt library. So I could see all the prompts. So similarly, you have seen previously this menu. Also, if I look more prompts in here, so I have all the list of prompts. I could select one of them, or I could look into all the lists. So here, vulnerability impact assessment. So I could click in here to see this. So I have just to add this ID. So I'm going to summarize from the ID that I put. In short, narrative indicates blah blah blah. So we're going to do all the steps, and you could add information to be following exactly the steps that I need. I could get back again to home and I get interested into this. So if I click into the prompt icon, so here's giving me a list of prompts. So getting started using these examples. Again, I have see all prompt book in here. I have also see all system capabilities from here. I could access it from here, so I could look into them. I have also this sources menu from here where I could look into the plugins. I could activate a plugin. I could look into here Microsoft plugins. I could also decide to set up plugin if needed. For example, here there is some plugins that needs to be configured first. I have also other non-Microsoft plugin that I could either enable or set up. And here in files, I could upload the files. And remember, we didn't select to allow the upload of files in this platform. Also, I have here the help section, so I could click on it. And from here, I could go to documentation, for example, and it redirect me to learn platform. Or I could request a direct help, so I could say what is the issue, and I will ask a help desk from an administrator. Well, that's it for this demo. In this second learning objective, we will describe core infrastructure security services in Azure. Now let's start talking about one of the tools that we have available in Azure to protect your network environment. Earlier on, we spoke about defense in depth, and we spoke about distributed denial of service attack protection. The aim of distributed denial of service attack is to overwhelm the resource on your applications and servers, making them unresponsive or slow for genuine users. A DDoS attack will usually target any public-facing endpoint that can be accessed through the internet. The three most frequent types of DDoS attacks are volumetric attacks, and these flood the network with seemingly legitimate traffic, overwhelming the available bandwidth. We have also protocol attacks, and these focus on exhausting server resources with false protocol requests that exploit weakness in layer 3 and layer 4 protocols. The third attack is resource application layer attacks. These attacks target web application packets. Well, inside Azure, you have an integrated service to help you protect your organization against these malicious attacks. The way it works is that Azure monitors the traffic coming into your network. Once it recognizes an attacker, it automatically blocks his traffic, but leaves your network open to legitimate traffic, so there is no interruption of service for him. In Azure, we provide you with an included free DDoS protection and two paid tiers, DDoS Network Protection and DDoS AP Protection. Both SKU had enhanced mitigation features to defend against DDoS attacks. The DDoS Network Protection protects your specific Azure resources in a virtual network, while the DDoS IP Protection is a pay-per-protected IP model. For more information, you could visit Microsoft Learn. Turning to Azure Firewall, I want you to take a minute and go back to the first session where we discussed defense in depth. The aim of Azure Firewall is to protect your perimeter and stop all attacks there before they reach your network. Azure Firewall is a scalable and high available solution that you can adjust to meet the needs of your traffic. Azure Firewall uses IP addresses, ports, and protocols for filtering and has built-in threat intelligence detection that can automatically block non-malicious IP addresses. In addition, Azure Firewall has the ability to do outbound SNAT and also inbound DNAT to communicate with internet resources. Azure Firewall integrates seamlessly into Azure Monitor, so you have access to all the logs where you can dig into different traffic as needed. In addition, it integrates easily with Microsoft Copilot for security. Alright, let's look into the next service. Web applications are increasingly targeted by malicious attacks that exploit commonly known vulnerabilities like SQL injection, cross-site scripting. Preventing such attacks in applications code is challenging. It can require rigorous maintenance, patching, and monitoring. Web Application Firewall (WAF) provides centralized protection for your web application from common exploits and vulnerabilities. A centralized WAF helps to make security management simpler, improves the response time to security threat. In addition, it allows patching a known vulnerability in one place. Instead of securing each web application, a WAF also gives application administrator better assurance of protection against threats and intrusion. Alright, remember the defense in depth model? Again, talking about it. What we covered until now was the protection of the perimeter of the network. Let's now dive into inside your network and get closer to your workload. The best practice in the area is to segment your network. Segmentation is about dividing something into smaller pieces. An organization, for example, will typically consist of smaller business groups such as human resource, sales, customer service, and more. In an office environment, it's common to see each business group have their own dedicated office space, while members of the same group share an office. This enables members of the same business group to collaborate while maintaining separation from other groups to the address of confidentiality requirement or keeping the information between businesses. The same concept applies with corporate IT networks. With network segmentation, you will be able to isolate resources and apply governance policies set by the organization. Now let's understand what is virtual network VNet. VNet is the fundamental building block for your organization's private network in Azure. VNet is similar to a traditional network that you would operate in your own data center, but brings with it additional benefit of Azure infrastructure such as scale, availability, and isolation. Azure VNet enables organizations to segment their network. Organizations can create multiple VNets per region, per subscription, and multiple smaller networks, which are subnets, can be created within each VNet. VNets provide network-level containment of resources with, by default, no traffic allowed across VNets or inbound to the VNet. Communication needs to be explicitly provisioned. This enables more control over how Azure resources in a VNet communicate with other Azure resources, with the internet, and with the on-prem network. Now, which service will be used to allow or block traffic within these VNets? Network security groups let you allow or deny network traffic to and from Azure resources that exist in your Azure virtual network. For example, a virtual machine. An NSG consists of rules that define how the traffic is filtered. You can associate 0 or 1 network security group to each virtual network subnet and network interface in a virtual machine, for example. The same network security group, however, can be associated to as many different subnet and network interface as you choose. An NSG is made up of inbound and outbound security rules. NSG security rules are evaluated by priority using 5 information: source, source port, destination, destination port, and protocol, to either allow or deny the traffic. As a guideline, you shouldn't create two security rules with the same priority and direction. Now, what do you think if we move to the portal and see how to create these NSGs? So in this demo, we are going to look into network security group, and for that we are going to redirect to the portal. So we are in the portal.azure.com. And in here, I've already created a resource group that I called it Lab SC-900. And inside this resource group, I have already created a VM and an NSG. So if I look into my virtual machine, I have in here the networking section where I could access to network settings. So if I look into the network settings, I see that I have a network card, which is my network interface. It does apply, or it is part of a subnet. It has a public IP address, and I see that we don't have any network security group, which we are going to get interest into to attach network security group to this virtual machine. So for that, we need really a network security group, and already create a network security group. And to create network security group, it's a really easy step. So you just write NSG, and you select network security group, and just hit to create, and you provide just the resource group, the name, and the region of the network security group to be created. Once you do create network security group, what I already have done, you will get some information related to this NSG. So in which subscription it's created, which resource group. And we have some settings, which is the inbound security rules that apply to these NSGs, and the outbound security rules that are applied to this network security group or NSG. And also where it is applied, this network security group, in which network interface or in which subnets. And we see it's not associated to any of this. So I'm going to attach it, associate it to my network interface of the VM, which is SC-900. I do this association, so all the rules that exist in this NSG will be applied into this network card. Once I have created this NSG and associated to my network card, and I'm happy with it, I could now start thinking which rules I'm interested to add and to apply to this network card and to this virtual machine. For example, I'm interested into adding inbound rule that is going to allow me to connect with RDP to this VM. So just say, so for the source, any source, or I could be specific. I could select the source port, or I could leave it non-specific. And for the destination here, I could say for any destination going from this NSG. And for the service in here, I'm interested into the RDP. So I'm going to look at it. There is many in here, like we see in many services. Once you select RDP, automatically it's going to detect that's for the port 3389, and it detects the protocol. And the action that I want to apply is to allow traffic that come in to this NSG. I'm going to set priority 1000, And for the name, I'm going to keep it at default, allow any RDP inbound. Once I'm happy with that, I add it, and I could think of anything else I want to create it. For example, outbound security rules, if I'm interested into adding any outbound security rules. For example, I'm interested into adding access for web from the VM to the web. So I'm going to select also from any source, and for the port, I'm going to keep it and change. And for the destination, I could say I want to target service, which is an internet. So I'm going to have access for the internet. For the service, I keep it custom service. So I'm not interested in anything of this. And for destination port, I could say 8080, or could put a star in here saying any port range. And I will keep it as the default name, and I really want to allow or deny that traffic. For example, I don't want them to connect to internet, so I'm going to deny this traffic. Once I'm happy with that, the VM will now have no access outbound to the internet, and it will be reachable through the RDP port. So that's what I wanted to show you for this demo. Thank you. Now that you have got your firewalls and network security group in place, and that you feel pretty good about your defense against external threats to your VMs, you want maybe to access to the VM to do some tasks. If you are thinking of using remote desktop protocol or SSH port, you have just exposed yourself to different kind of attacks. Azure Bastion is a service you deploy that lets you connect to a virtual machine using your browser and also using the Azure portal. The Azure Bastion service is fully platform managed PaaS service that you provision inside your virtual network. Azure Bastion provides secure and seamless RDP and SSH connectivity to your virtual machines directly from the Azure portal using Transport Layer Security TLS. When you connect via Azure Bastion, your virtual machine don't need a public IP address, agent, or any special client software to be installed. Azure provides you with a solution where you can keep your valuable items such as passwords, API keys, encryption keys, and certificates. Azure Key Vault is a cloud service for securely storing and accessing secrets. A secret is anything that you want to tightly control access to, such as API keys or passwords or certificates or cryptographic keys. When you use Key Vault to store and manage these secrets and keys, instead of putting them in your application code or configuration files, this way you can avoid exposing them to unauthorized parties or compromising your security. But how do you access your secrets and keys in Key Vault? Well, you need to authenticate yourself first using Microsoft Entra ID. Once you are authenticated, you need to be authorized to perform certain operations on your secrets and keys. You can use either Azure Airbag or Key Vault Access Policy to grant or deny permissions to your secrets and keys. For example, you can allow some users to read your secret, but not to write or delete them. Another benefit of using Azure Key Vault is that you can monitor who accesses your secrets and keys and what they do with them. Azure Key Vault has two service tiers: Standard, which encrypts with a software key, and also the Premium, that include hardware security session like HSM to protect your keys. In this session, we described a really useful tool, which is Microsoft Security Copilot, and then we described the core infrastructure security services in Azure. Remember that all these materials is available for free on the learning path on aka.ms/SC900. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this class or search out your next favorite one on Microsoft Learn.